everyone. This is the lesson video for 8.3 graphing linear equations. So trying to find my pen that I like using, my red one. Anyway, so this is the first time we've graphed a little. Now we're really delving into the two main methods that you're going to be using to graph linear equations. First of all, a linear equation is an equation whose graph is a line. And a line is like something that if you have 2 points and you connect them, when you connect them, that is a line. Something that is straight, when you connect, that's a line, okay? There's no curves or anything like that in a line. It's just straight. It's like it's you and a friend are 2 points and you have a string and you hold it taut. That creates a line, right? Continuous graphs, when a graph can be drawn from beginning to end without any breaks. The easiest way to understand continuous is when you have a point, again, when you have a point from here to here, continuous is when you start drawing, you're not picking up your pencil. That is continuous. So a continuous graph could look like this. Okay, that's continuous because you haven't picked up your pen or your pencil. This is not continuous because there's a break and you picked up your pencil. So continuous means there's absolutely no breaks. So look at these 5 graphs below. Which of the following graphs are linear and continuous? Okay, you can select more than one of them. So I want you to think about it using those 2 words that I talked about up there. And which of them are linear, that actually are a line, and is continuous. So graph over here, is this linear? No, it's not linear because it's not straight. So, but it is continuous because there's no breaks in the graph, all right? But this is not continuous. Not linear. Over here, is this linear and continuous? Again, it's a little wavering. It's like moving around a little bit, so that makes it non-linear, okay? Excuse me. But it is continuous again. So, but it doesn't meet both criteria, so that's not both of them. The graph down here, is it a straight edge? Yes. Is there any breaks in it? No. So this is continuous and linear. Over here, is this linear? Well, if you are connecting points from these two and you're connecting from here to here, but it's not continuous because there's a break. You can't draw this entire thing without picking up your pencil. So this is not continuous, but it's 2 separate quote-unquote linear. And then the last one over here, is this continuous and linear? Is it straight? Yes. Is there any breaks? No. So it meets both criteria. So these 2 are continuous and linear, okay? So when you're dealing with linear equations, it's going to form a line like this. Graphing lines. So there are 2 methods of graphing lines. You did the Explorer activity on Friday on this, so you have a heads up on the 2 methods. One is using a table of points, which you've been doing repeatedly over the last few weeks, and the other one's using the start value and the rate, which is going to be fairly new to most of you, okay? So using a table, I'm not going to get too into this. I'm going to go really quickly on this because you've been doing. Create an input-output table with a minimum of 3 points. Connect the points to form a line. Tip, use x values that would fit on the graph provided for you, meaning don't use x equals 10 if it doesn't fit on the graph, okay? That's just something that will help you. So there are over here your graph y equals 10 minus 3x. There's provided the input values, the x's, and you're going to try to find your y's and then the ordered pairs. So this is going to be y equals 10 minus 3 times 0, which is 10 minus 0 is 10. Y equals 10 minus 3 times 1. So 3 times 1 is 3, so 10 minus 3 is 7. Y equals 10 minus 3 times 2. 3 times 2 is 6, so 10 minus 6 is 4. Y equals 10 minus 3 times 3. 10 minus 9 is 1. And now you're doing ordered pairs. One thing I'm seeing some of you do in prior assignments is you're writing this, 0, 10. This is an ordered pair. This is nothing. Okay? Ordered pairs require parentheses. That is, you cannot just assume that the person on the other side understands what you're talking about. 0, 10 absolutely means nothing. So make sure you put parentheses around ordered pairs because this is what's signifying that it's a point on a coordinate plane. Over here, 1, 7, so 1, 7. 2, 4, 2, 4, 3, 1, 3, 1, and now we're gonna, 1. Now we're gonna graph these. So remember, the x value is a horizontal and the y value is vertical. So 0, 10. It's right there, 1, 7. 2, 4. 3, 1. And now what you want to do is connect the dots the best way you can with this straight. Draw it as straight as possible. Because I'm working on a computer, am going to use the line tool like this and draw it. All right, and the arrows help because arrows mean that it's never ending. I'm not going to make a big deal of it now, but I guarantee you a teacher in the future will, okay? So you're just connecting the dots and this is your line, okay? I want you to pause the video and do the you try problem on your own, and then check your answer with me. So this is the completed graph right here. So just check to see if your answer matches up. And again, try to do the straightest possible line that you can, even if you want to use an index card or a ruler to draw it and connect it if you're doing it on paper, or just use like tools, like shape tools if you're doing it on a computer. Okay? Now we're going on to, method number 2. Just trying to scroll. It's not letting me scroll. Okay, back. So I scroll down. So method 2 is using the start value b and the rate or rate of change, as I call it all the time, m in y equals b plus mx. So first thing you want to do is identify the start value b from the equation. Then you want to plot that point. This point, this point is called the Y-intercepts. Why is this going away? Pin it. This point, sorry, computer's being a little funky right now. This point is called the Y-intercept, and I'll talk about what that means when we do the first problem. You have to plot that point. Just do it right away. Then identify the rate m from the equation. Write it as a fraction. This matters because remember, m is the change in y over the change in x, and you need that rise over run concept when you're graphing. And again, when I go through the problems, you'll kind of understand a little bit more. Then use a rate to find a minimum of 2 additional points. You want 3 total points. That first one's coming from the start value, the y-intercept, and the other 2 are coming from using the rate. Then, just like the last method, you're connecting the points to form a line. So let's go through this process with problem 3. So graph the following equations using start value and rate. So first, identify your start value, which is, remember, it's b, okay? Your start value is b, and it's the number that's not next to x. So even if they write it in y equals 0.5x plus 3 form, because x is next to 0.5, 3 is your start value. So this is going to be your start value. And that also means it's your y-intercept. What that rep means on a graph is that it's intersecting, it's crossing the y-axis at that point. So that point is 0, 3. This always happens with the start value, because the whole purpose of the start value is where x equals 0. I talked about that in a table. So on your graph, x is still equals 0 here, and the value of y is depending on where that b value is. And now you're going to identify the rate of change. So this is going to be 0.5, and I told you to write it as a fraction. So 0.5 over 1. What this means is the rise over run. So the top number, because it's the y, it's up and down movement, that's what rises when you're taking the elevator up or down. And the running, it's flat. You're running on a flat surface, is going left or right. That's what you really want to think of. So because this is positive, you're going to go up 0.5 spaces. So you're going to go up 0.5. You're going to go about half a block. And then it's one space to the right. So up 0.5 and one to the right. So from that point, you're going to go up 0.5 and then one to the right. And that's your next point. Then you're going to go up 0.5 again and then go one to the right. So what you're doing is creating steps. These are creating steps. Okay? You're going up 0. You can keep doing it over and over. You can get as many points as you want. Go up 0.5 and then go to the right one. Go up 0.5, go to the right one. And that's how you get a linear equation, a graph of a linear equation like that. And you're just going to connect the points. This is the best I can do this time. And that's your first graph. All right, let's do another one. So y equals 8 minus x. Remember, what's the number in front of x? That is a 1. Okay, so make sure you put that over there. What's your b value over here? The one that's not next to the x is 8. So b is 8. Your y-intercept is 8. So we're going to graph that first over here. Your m is 1. Actually, I made an error. Did you see the error that I made? It's actually -1. You got to take the sign that's in front of it. It's -1, and you have to make it a fraction, so -1 over 1. And when I see a negative rate of change, I always make the top number negative. It just keeps it consistent. And now you're dealing that rise over run mentality over here. So this time, because it's negative, you're taking the elevator down -1 spot, and you're going to the right one. So from that point over here, you're going down 1 to the right one. Going down 1 from there to the right one. Going down to the right one. And you can create as many points as you need from that. And you connect them. And again, my connecting with this is not always wonderful, and I'm not going to judge you on yours either. Just do your best with it. But that's how you graph a linear equation using the start value and the rate. So I want you to pause the video right now and do the try problems, and then check your answers with what I get. All right, so these are my answers to the you-try problems. And whoops, I forgot to create the line here. So I'll just do that. Oh, this is a terrible line. I don't know if I can. It's letting me move it. There you go. That's your line. And these are the lines. Check to see if your answers match up. See what you got wrong. One thing I do want to point out, if you noticed, is when the rate of change with the m value is positive, if you look at the graph left to right, it's going in the positive direction. All right, everything is moving towards a positive direction. When the rate of change is negative, like this first one on the left here, it's going downwards left to right. The same thing happens up here. This is negative, so it's going downwards, and this is positive, and it's going upward, okay? So this is your first lesson on graphing linear equations. If you have any questions, make sure you come to my office hours today or tomorrow, or like today meaning Tuesday or tomorrow meaning Wednesday. I think that's when I'm assigning this. Not sure. Whenever it is, just come to my office hours when I have them. All right, bye guys.